Video on?
Yeah, good evening, ma'am. Go ahead. Yeah.
All right. Hello, good evening.
Participants should respond in the chat box. Yeah.
That's fine. That's fine.
Yeah.
Good evening, everyone. A very happy Raksha Bandhan to all of you. Thank you to Buds Academy and thank you to my colleague Harita for inviting me for the session. So my name is Safa. I work as a senior admissions counselor for the USA department at Pac Asia, Hyderabad. I've been invited to speak a little about artificial intelligence and machine learning prospects in the US right now. So generally, we do work with students who want to pursue their bachelor's and master's abroad in countries like USA, Canada, Australia, Malaysia, Singapore, like that. But I believe the focus is on USA today. In case you want to inquire about anything, please put it in the comment section. I'll keep a check here and I'll try to answer if you have any more questions. Okay. Are we good to start?
Yeah, go ahead. Go ahead, ma'am. Yeah.
All right. Okay, so right off the bat, there is a huge scope for artificial intelligence and machine learning in the market, especially in the USA right now. Scope for students to pursue masters, and after masters, the job market is quite good. We have seen an increase in subjects and fields like business analytics and financial technology right now in this 2023-2024 year. But till now, it was still computer science, IT, AI, ML. So a little bit about the USA education system. It is slightly different from India. Here, if you study a bachelor's for 3 years, you will be having a fixed curriculum. You'll be taking fixed subjects that everybody is taking with you when you graduate. But in the US, you have flexibility of choosing your major, choosing the classes that you take, choosing the professor who teaches that. So computer science is an overall major program, a major department in which artificial intelligence, machine learning falls. So there are programs in the US where it is straight MS artificial intelligence, or there are programs that are MS computer science with a concentration of artificial intelligence, or MS computer engineering with a concentration of artificial intelligence. What you can expect to learn from this program, in general, the curriculum varies from university to university, but generally they focus on designing so the design and implementation of intelligent systems where you perceive, act, learn in response to the environment. So basically what you do in the course as well, utilizing machine learning techniques to improve performance of systems, or to derive experience-based learning techniques or experience-based models for problem solving. I have had who wanted to creatively incorporate web development and AI as well. This is something new, not very well known. There are students who are currently doing research in it and trying to incorporate. There is a huge market for even retail robotics in retail, robotics in agriculture. So if you're leaning more towards robotics, you should definitely choose a concentration as such. Any questions specifically about any concentration in the crowd here? Can I know what kind of concentration or what kind of area you're interested?
Participants can put their queries in the chat box if you have any specific questions related to your future. If you have any queries, so that ma'am will try to get address few of your queries. If necessary, you can unmute also. Yeah.
Correct.
Yeah.
So I hope you all have a basic understanding of programming languages, Java, Python. If you learn that from here, that will be greatly helpful for you. Pursuing a master's is not that tough, but getting a job after that, you have to make a well-rounded profile. So if you are doing your bachelor's from India, completing a bachelor's and gaining at least 1.5 years of experience, then applying for a master's will be beneficial, because you already have a basic understanding of the industry and the work field from India. You complete a master's, you gain a specialization, and then ahead you look for a job. So when you're hunting for a job that suits your needs, they already have a good reflection of your profile on your resume, since you've already had some experience in India. Hello.
Yeah,
Hi.
put your queries if you have, so that yeah, just one query is there. Just you see, yeah.
Yes. Jobs after masters in the US. Right now, actually, India is doing quite well, because a lot of industries and a lot of companies from India are setting up headquarters, South Asian or Asian headquarters in India, especially in Bangalore and Hyderabad. So there are a lot of job opportunities coming forward after maybe in a 5-year or a 8-year span in India. But as of now, definitely USA. There are a lot of job roles in terms of like engineering, or if you want to become a data science specialist, if you want to go more in research, you can do machine learning research, or you can gain a specialty in machine learning. These are job roles that are available plenty in US. So when we think of USA and IT, we generally focus on San Francisco or Silicon Valley as the IT hub. But actually, USA has a lot more opportunities than that. If you look into states like Virginia, Georgia, Michigan, Ohio, Missouri for research, or Dallas, Texas. Dallas is a huge hub right now. So Texas, Houston, Dallas, these are good cities and states if you want to look particularly into jobs. And there's a lot of Indian crowd in these states as well.
Yeah, any other queries? Yeah, some AI ML tools.
Yes.
Yeah, participants can put it in the chat box, so that your real-time question will get addressed. We'll be happy if you speak in the chat box.
Right.
So
there are a lot of AI tools actually. Are you talking in terms of master's program, or just job? In terms of job in the US, what tools you need to learn?
yeah, Satyendra Prasad, you have to modify your queries if, yeah.
Okay. For job, so make sure you research on the industry before you apply for a job. There will be different tools you need to learn depending on the industry. Okay. Right now, I mean, for a general industry tool, I can tell you about PyTorch or Cafe. Wait, I can put this in the comment section. 1 second. I'll put some of the trending tools that you can learn. So the best way to navigate getting a job in the US is to study and then get a job. H-1B visa from India is very limited. They take around 20,000 applicants from here, from India. From USA, you will have a pool of 40. So it will be better if you apply from the US for an H-1B. You have more chances of getting it from there. Directly, if you want a job, you have to work in a company in India that can help you transfer there, if they have any branches in the US.
And
So I would suggest gaining some skills from India. If you can take at least any courses, or if you don't want to do a master's in the US, if you don't want to make that investment, at least learn some courses or gain some skills from here. Any natural language processing or statistical programming, something like that.
Especially for admissions, which university they can try as a common kind of thing.
So a lot of students apply in Texas for engineering programs, California side and Texas side. But if you have a good profile, if you have had a good percentage or CGPA in your bachelor's, you haven't failed a lot of subjects and written too many supplementaries, then you have a good prospect. So look into Texas universities. California State Sacramento is a very good university for that. University of Texas at Dallas or University of North Texas. You can also look into Lewis University in Illinois. Look into some Michigan universities as well. Central Michigan University is also good for engineering. New Jersey actually is a huge industrial area. So if you're looking into Montclair State or New Jersey Institute of Technology, these are good universities for engineering programs. Yes, hi Prateek.
Regarding, actually he joined right now. So,
okay.
Yeah.
Okay.
So jobs and education in abroad in AI, ML and IoT areas, students' background might be mechanical, might be civil, might be electronics, how they proceed.
Okay. So if you're not from a related background, if you haven't done BTech CAC, then your best option is information systems. Try MIS, Management Information System, or Information Sciences, or Management Information Program. Can you suggest any other programs in USA with less cost?
Less cost.
Depends on, so what is your budget? Usually USA education for masters, it will be an average of 35 to 40 lakhs for 2 years. If you're looking into completing it early, or if you're looking into a budgeted university, you have to look into a university where tuition fee is less. Otherwise, it's not really program. You pay credit wise. So if you're taking credits in MBA or MS, it doesn't really matter. You're paying per credit. Embedded system design, best is computer engineering with a specialization in VLSI or embedded systems. Which course? It is MS engineering or electrical engineering course. Leaving masters, I think for less cost, it will be probably an MS business analytics or an MBA business analytics program.
They're talking about visas also.
Right. So yes, it is tough getting H-1B from US. They pick out 60,000 applications, in which only 20 to 25 are picked out from India. The rest 40 are from US. You can join for a 1-year program. So for visa, your F1 visa is issued for 5 years, but your program will be 2 years. If you want to join a 1-year program, make sure it is STEM designated. So STEM is science, technology, engineering, and mathematics. This gives you an extension of 2 more years stay back in the US. Otherwise, after your graduation, you're eligible to stay for 1 year in the US. If your program is STEM designated, you can stay back for 2 more years, extend it. There are 1-year programs also, but very limited in the US.
Yeah. How your organization will be able to help them? If anyone is interested to proceed, you can talk about your organization also a little bit so that they can get some
Sure. Requirements to get into US universities. So you need, for a bachelor's degree, you need your 10th and intermediate, 10th and 12th, letters of recommendations from your school, resume, and all your original academic documents. For masters, you need to have 10th, 12th, bachelor's or in all individual mark sheets, consolidated original degree certificates, letters of recommendations, and you need to write English language exams. So English language exams are for all, for bachelor's and masters. You can either write an IELTS or a TOEFL, TOEFL, TTE. Duolingo is also widely accepted in the US. So you can write any of these exams, get at least a 6 up, 6.0, 6.5 in IELTS, 81 above in TOEFL, PTE 52, 53 above, and for Duolingo at least 110, so 110 above. These are basic requirements for USA admission. So what we do for any consultancy, actually, what we'll basically do is we'll evaluate your profile. Your academic profile has to be fit for admissions first. Once your profile is set, eligible for USA masters or bachelors, we shortlist universities, 25 to 30 universities for you. You can do your own research. You can have your own preferences. Maybe you have a uncle in Chicago and you just want to be there near Chicago or something. You can also finalize according to your preferences. We apply for universities, chase for your admissions, and do the entire visa immigration process, help you land in the country. So these are the services from consultancy. What you can do from your end is collect all the original documents. There is a huge problem of fake documents, students getting deported. Very sad. It's been in the news all over. Don't take any fake academic or financial documents. That does not look good for you. You get a 10-year ban. Even if you try for any other country, it's very difficult. You might not ever get to go to another country for study. So please make sure you are securing your career in the right way. Okay.
So, any other queries, participants? Otherwise, ma'am will brief about how they will help to you people if you want to get in connect with your organization for future requirements. Ma'am, you can explain also them which kind of help your organization will offer them, especially for the foreign education universities, how to select visa process. And they have a lot of queries, but they may not be able to display their queries here. Yeah.
All right. So
how they can reach with you,
sure.
like that, your organization basically. Yeah.
So there are two levels. The first part is getting admission to a university, and the second part is getting your visa approved to travel. So for admissions, we do a document collection and verification so that university does not have to take a longer time in processing. The most complaints that we get from students about USA is that it takes very long time. So there are three major intakes in the US. The first is the fall intake, which is August. The second is January intake, the one we're processing right now. January intake is in the spring intake is in January, and the very small minor intake is May summer intake. It is almost the same for Canada. September, they start in late September, and then they have a spring and May summer intake. For Australia, it is July. So July, November, February, these are the major intakes. UK is also almost the same. September, January, and May. So what we do is we evaluate your profile, send you a list of universities that you have good admission and visa chances with. You have to select 5 to 6 universities. We take care of the entire admissions essay, application process, admission process. So we have a lot of tie-ups in universities. We've been working in the industry for over 25, 26 years. So we have tie-ups with universities where we push for your profile, where we advocate for you, where we represent your academic profile, try to get you admissions. After you secure admissions, there is an I-20, there is an immigration document. So for USA, it's an I-20. For UK, it's a CAS letter. These are all immigration documents that start your visa processing. For visa processing, you need to show financials and university academic documents. So an admission letter, an I-20 is a university document. Your academic documents are your 10th, intermediate, all your certificates. These are academic documents. And financial documents will be sponsor bank statement. So let's say your mother is sponsoring you, your father is sponsoring you. You have to arrange for the transaction history of the past 3 or 6 months to show that you have financial capability of completing a course or completing a master's in the US. If you've been working for 7 to 8 years, if you yourself have a genuine experience of 7 to 8 years, you may also show yourself as a sponsor. But if you only have an experience of 3 years, 5 years, best to show a mother or father as a sponsor. There are students whose uncle, aunties help out. They can also be sponsors genuinely, but the best thing to do is have them coordinate with your parents and show sponsorship as parental sponsorship. That appears, or that is better at the time of visa interview with an officer. So for USA, you have a visa interview. For Australia, there is a GTE interview with the university. For UK, some universities ask you for interviews, some may not. Canada, there's no interview. In an off chance where they really want to meet with the student, they might call you. But Canada, there's no interview for visa. So once your visa is done, we help you secure your visa as well. Apart from the back-end application process, we also train you for interviews. So there are mock interview sessions where we'll one-on-one have training sessions, what to say, what not to say, things like that. So once your visa is secure, we coordinate with the university for your arrival. So getting all your immigration documents in, your class registration, tuition fee payment, health insurance. These are the next steps after visa approval before landing. Once you land in the US, the university conducts an orientation for international students where they help you to set up your bank account in the US, or if you need a SIM card, if you need additional immunizations required by the university, then they conduct a 2 to 3 days orientation for that. You can also meet with fellow students, academic advisors during that time, and do your own networking as well. So this is the entire process. More or less, it's the same for the planet actually. More or less, USA, Canada is the same. UK, Australia is the same. There are different things. There are different levels of processing in between. Please get in touch with me if you're looking forward for education. Get in touch with me. If it's for job, my best advice for job is to get a company from here that will help you transfer out into a job or into a branch in the US. Otherwise, if you're just starting from scratch and applying, sending in your resumes, networking on LinkedIn just for a job in the US, it's going to be very difficult. For an H-1B, you have to hire an attorney who files the H-1B for you along with an employer. So it's a very whole tedious process. It's very difficult from India. Not impossible, but difficult. I'll just put my contact in the comment section. If you have any questions, please feel free to reach out to me. Thank you, Buds Academy. Thank you, Arjun sir, for inviting me.
Thank you so much for clearing our queries. Some of might be interested for pursue their careers. Over to Sai.
Yes, sir. So thank you so much, ma'am, for spending your time and sharing your insights. They were really grateful and they would really help all our students. So thank you, ma'am. Once again, I would like to extend a formal thank you on behalf of IIT Pune chapter and Buds Engineering Academy. Thank you so much.
Thank you.
Moving on, I would like to introduce our second speaker for today,
Amit sir,
Mr.
can you
Amit
hear me?
Kumar.
Yeah.
Yes, sir. Mr.
Amit
Amit
sir, can
Kumar,
you hear
sir.
me?
Yes, sir.
Yes.
Yeah.
Yes,
Okay,
sir.
so go ahead. Sir is there. Yeah,
So,
go ahead.
sir is currently working as CTO at Pragya Mitra. Sir has an expertise of more than 15 years and experience in system development, training, and project consultancy. Sir's previous experiences with IIT Delhi, DRDO, Government of India, National Informatics Center, and IBM India as project consultant as well. So, sir, once again, I would like to welcome you on behalf of IIT Pune Chapter, Buzz Engineering Academy, and Civic Incubation Center. And I would request you to please take over the session and guide the audience.
Thank you. So, hope I'm good audible to each one of you. Very good evening. Am I good audible? You can just confirm me through chat window.
Yes, sir, you are audible. Go ahead.
Great. So first of all, thank you, Arjun sir, for inviting me for this wonderful session. Though it was a very short on notice, but yes, I'll try my best to share the insights on the topic which you had told. It is related to the artificial intelligences and machines learning into IoT. Am I right? So this is the last session of this series that is going on. Am I right? Arjun sir, this is the last session today?
Yes, sir. Tomorrow is the valedictory session.
Okay, tomorrow is the valedictory. Okay. So all the participants, you must have gone through very deep insights of the IoT and the related technologies throughout this these sessions, which must have progressed through. And I would say that IoT is become a movement, and we are into this movement now. So all sorts of technologies are putting and taking their role into IoT, easing our lives, making humankind advance and easing our tasks day by day. So today I'll be sharing some insights of artificial intelligences and machine learning into IoT. So how these technologies could be beneficial, where all these could be utilized, all these things that I want to talk in this small time period. And as I was introduced, so I'm Amit Kumar Chaudhary. I lead the technology division as a Chief Technology Officer of Pragyatmika. We are headquartered in NCR, Delhi, and having operations in major metros related to the technology consultancy, R&D, skill development, all sorts of things into the domain of industrial electronics, electric vehicles, UAVs, all these. So this is the time where industrial automation is the most buzzword today. And not only the industrial automation, but we are hearing a lot about Industry 4.0, Industry 5.0, the terms like industrial IoT, the terms like cybersecurity, the IoT security. These are the most buzzwords. Thereafter, it is related to the smart manufacturing, sustainability, smart cities. Thereafter, it is the circular economy. All these terms, how these all are interrelated, how all of these are playing a role into the IoT, and how all of them are playing a role into easing our lives today. That should be a talk for me today, and how this all are interlinked, how the technology is integrated, and how we can develop certain of our solutions if we want together. So industry has moved from Industry 4.0 to Industry 4.0 now, and now we are actually setting the standards for the Industry 5.0, where we are talking about the sustainability and the circular economy. But right now I'll talk about till Industry 4.0, where there is a differences of implementations of cyber physical systems, the Internet of Things, the IoT security things, and the self-decision making. So from autonomy to self-decision making, how it is happening, and that is the backbone for this integration of IoT and artificial intelligences. In Industry 2.0, we had the mass assembly line productions and everything. From there, we have the computers and the HMIs came into picture, where there is a automation is there. So you feed the program into your HMI, and you feed the program into your automation systems, and through the HMIs, the processes used to happen. There is a no backward and forward linkages we have. It is a single directional, unidirectional task execution that we see in the industry 3.0. But now that is not enough. We need a real-time control onto the production process. We need the real-time insights from the factory floor, from where the production is happening, and not it is the factory floor or the shop floors, but in all of the processes. It is into our deliveries process, into our maintenance process. Everywhere we need a real-time actions, real-time insights, and real-time controls. And that's where this Industry 4.0 implementations amalgamated with this IoT and AI is in picture. And once this leads to the waste to utilization, they have the circular economy and sustainability related to your environmental sustainability, to the living sustainability, everything is considered. There, these standards for the Industry 5.0 will be considered over there. So I was taking some examples, like all of us are using the deliveries, like all of you are using courier services maybe. So in a normal courier, what it is that the packets are moving from hop to hop, one place to another. And as the packet moves, you get the update that your packet is at this destination. And once at the final destination, when the courier guy is for the delivery, for the packet, you just get to know that my packet is out for delivery, just a kind of information. If the owner of the courier or the management of the courier company wants to get a information that in real time, how many number of packets are getting delivered by the courier company in an hour in a particular zone or in a particular city, that insight he will not be able to get. He is having the means of IoT, he is having the integrations of communication onto the packet scannings and everywhere, where the information is getting updated, but meaningful information from it related to a real-time insight, he will not be able to get if he is not capturing the live data, he is not capturing the live delivery of the packets. And if we implement the live delivery parameters over here, and we model it into some system, there we can, and it is possible, and it is getting by, like Amazon delivery, the Flipkart delivery, or the other advanced delivery companies. There are the delivery aggregators. They are integrating these things into their systems, where they are modeling that in a real time, how many number of packets they are getting delivered in a particular zone, in a particular city. So I just want to make a difference that how integration of a technology, it is just the IoT. If it is just the IoT, you are only having the information that your packet is getting delivered from hop to hop. You don't have a real-time control, you don't have a real-time insights, you can't plan any of a thing about your delivery patterns. But once we model it into a system, feeding those real-time data into it, and then we will be able to plan better using a means of IoT, that AI, that are related to something business outcome of it. So that's how this integration of the technology is very crucial in any of a sector today, where we are using for the automation purposes, for the easing of life purposes. Another example we can take, like there is a maybe environmental sensors or temperature sensors, or maybe some building automation systems we have established, where we are getting the real-time parameters of the building, whole building. That is a building IoT I'm talking about. Now, there is a certain of a parameter changes has started happening maybe in the temperature. of that particular of a particular zone in that building. Now, there are two ways. Either there will be a dashboard system on which the person is sitting, keeping his eyes continuously on the screen, and he will be keep monitoring that where the temperature change is happening, so that he can sense that is anything unusual is there in that particular corner of that building. Or we could have some model into our system which can sense the change into that temperature, accordingly can raise some alarms, can raise some kind of information onto the dashboard, can send the analytics information to the control parameters, to the control centers, and based on what the corrective actions could be taken. Also, there is a possibility that it was not a real change, it was a malfunctioning, or it might be some attack that might have happened onto your network. That thing also should be filtered out, and all these things are possible once we are integrating this artificial intelligences models into our the amount of the huge amount of data that we are gathering, that we are generating through our IoT sensors. So the integration is very necessary nowadays to increase your production efficiencies, to reduce the intervention of the human, to reduce the efforts the human is making to do any of a task. Human intervention is lesser. There is a less chance of getting the errors of the system also. But at the same of a time, there is a huge amount of a data manipulation, because there is an enormous amount of a data that we need to gather through the means of the sensors. There is a requirement for the intelligence, and this will lead to the autonomy of the system. So this industrial revolution with the integrations of the IoT, AI, ML, all big data, analytics, everything is together, leading to this new generations of the implementations of IoT. And that's why we call it that IoT is not only for communication now. IoT, it is a consumer IoT, is remained as a very smaller term now. Now there is an implementation of IoT for the specific domains, for the specific sectors. Like you are using it for the industrial use cases, it is the industrial IoT, where we have the specifics related to the autonomy of the systems, an enormous amount of a data storage, the enormous amount of big data analytics that we do for the control of the connected HMIs. Then there are, if we are using the IoT for the purposes of like a body electronics, maybe for wearable devices, maybe for your health parameter gathering devices, some glucometer devices, some BP monitoring devices, where the parameter of the IoT will be lesser. The parameter of communication will be smaller, because it might be a low power device. It might be a small footprint sensor device. But here the requirement of the modeling is higher, because you have to give the analytics to the person according to his needs. It must be personalized. It must be personified, so that the person should get the exact information, exact analytics about his health parameters, what his condition is. It should not be a general. So there, the usage of the AI is higher compared to the means of IoT. Similar, if it is the connected vehicle we are taking into picture. So connected vehicle will be generating a TBs of terabytes of data. The vision data, thereafter the sensors, the road traffics, thereafter the condition of the vehicles, every data that it is gathering through the means of the sensors, that has to be modeled, and that will be utilized further for the assisted drive, a good assisted drive of that vehicle. So there, the integration of this AI and IoT together, making the use case for the automotive IoT is there. So there is a specialized in each of the domain, there is a specialized requirement of the connectivity. There is a specialized requirement of the models. There is a specialized requirement of the sensors, and there is a specialized requirement of the handling of the system is there. And that's why IoT is not remained a general implementation of the IoT today. It has a special use cases for each and every segment. And wherever it is required, you will have to give the intelligence, you will have to provide the autonomy to the systems, so that the higher the efficiencies, the higher the throughput that you want from the system, you should be able to get it. And that's why we are talking today, the integration of the technologies. So this leads to enhancements of the manufacturing processes first. So we are having the 3D printers, cobots, robotic process automations, where man and machine both are working together, knowing the existence of each other. It is not just an assembly line, or it is not just a pick and place arrangement, what I'm talking about. It is the simultaneous existence of robot and the man together working on the same assembly line. That's what the integration is taking place, and that's what is the requirement. That's what the benefit that we have. And both of them, knowing each other, adjusts its efficiency so that both of them can work together on the same of assembly lines. Then for communications, there might be required the near field communications, where the control center, the central control of that robot will be working together with the clutch and the hands, or maybe a remote control where you are sitting at a central head office and controlling the robot through a remote means, where there is a requirement of a connected and the accurate and the timely availability of the Internet of Things means. So that is the benefits that we are having today with the help of this integration in the manufacturing processes. The second of a benefit that we get is the integration of the products and services together onto the value chain. Like all of you are wearing watches. Just think of a normal watch which you have. Maybe it is a digital watch, maybe it is a old school that dial clock watches, like maybe HMD or Titan. There are many of the companies, those who are making the watches. So what happens in them? You go purchase a watch, you just wear it, you use it for the timing, you use it for maybe seeing the calendar, you may use it for setting certain alarms. That's it. Tomorrow, if like Titan wants to send you some information of the watch on that watch, or maybe if Titan wants to just gather information that who all are wearing my watches in real time, he will not be able to gather that information. So that is a implementation 2.0 or 3.0, where some sort of automation is there that maybe he can take the information through his vendor network. But think of an Apple Watch today. The product is same. I can have an Apple Watch. You can have an Apple Watch. Someone else also can have an Apple Watch. All of you are having the same hardware profile, same hardware product, same connectivity is there, but models on top of those products could be different. Models in terms like, I am a health freak person. I can model my watch to give me the insights on the latest of the health, which would be good for me. Maybe you are a news freak person, so you can model your watch to give you the latest of the news information. Someone else is a sports freak person. He can model his watch for the latest sports information or the latest sports insights, or maybe the insights related to his running parameters. So the product is same, but on top of that, we are adding the various services through a models, and that is creating a separate value chain for that product. So that's what this benefits we are getting with the integrations. And not only this at a smaller level, but at a larger level, we can have the process level managers and the HMIs, cloud connected HMIs together, which can work and which can give the integration into the factories also. So that's the benefit in the manufacturing processes. In terms of a products, every of a product is now integrated with the apps, which is many of them could be controlled through your voice, gesture, maybe through the previous of your personalized settings, which you have done for your apps. Based on that, you can get the special features of the product. It is always connected through the means of a IoT. And also, it is the integration of the new and legacy technologies. So it does not mean that whatever is old, that will be left. Once we are integrating, once we are designing any of a system today, we always take care that the legacy systems should also be integrated into this, so that any of a device should not be left onto bringing onto the network. And then it is the cloud integration that we want today. Till Industry 3.0, it is the ERP is good enough. But once we are in the environment of Industry 4.0, where we have the integrations, it is necessary to have a cloud environment where either you can run the insights, either you can run the intelligence onto the edge devices, or maybe some part on the edge device, some part onto the cloud, and then together can generate the analytics for the working of your devices. The most of the benefits, because everything what we do, it must be converted in terms of the revenue. It must be beneficial for the businesses. And that's where this digital services is an added benefit what we get with the integration of the technologies. And those digital services will be recurring, will be giving the revenues to the company again and again. Like maybe Apple has made the watch once, but now tomorrow if Apple wants to show you some advertisements, and by viewing those advertisements, you can also earn, and Apple will also earn through his ad network. So that's a revenue that's what we can get. Predictive maintenances. Once we are so dependent on the technology, once we are so dependent on the machines, then thinking of that the machine will get down for some time, how our lives will be. Just think of any of a device which you are using on a regular basis, and if that device gets down, how difficult your life would be. So that's where this predictive maintenance, we are using the models for the predictive maintenances, which can tell you in advance that your device is going to be bad. Maybe your air conditioning device, a connected air conditioning device in your home, that can tell you before that when it should be maintained. Maybe you have a general maintenance routine of 6 months. At every 6 months, you are maintaining your air conditioning device at your home. But this time, summer was really very high, and you have overutilized the air conditioning device. So it must be maintained before, because the motors might have run more, the temperature might have been higher, the compressor must have lost its efficiencies. So predictive maintenances models will be able to tell you beforehand that this must be maintained now, this must be serviced now, so that you can use the systems without of a fail proof. And why only fail proof? It will also save your costs. Like if the compressor is running at a higher of a current, so it is definitely adding the electricity bill and making a hole in your pocket. So if we maintain it beforehand, if we maintain it at a time for the predictive maintenance, as per the predictive maintenance schedules, it will happen. It will consume the less energy and saving some money into your pockets. So these are the benefits that we are getting using the integrations. Till now, any of our questions, if anyone is having, I would like to
Participants should put queries. Sir will, whatever you have, any query, any kind of query, sir will try to tackle in his session. But still, if you have any queries, you can put it so that Sir will inculcate your queries in his talk further.
Okay, if anyone is query, you can open your mic and just ask me.
Yeah.
I'll pause for 1 minute.
Yeah.
Yes,
If
participants can just raise their hands if they have any query. I will give you the microphone access.
yeah. Open it, mic. Yeah, give the access. Yeah. Satyendra Prasad want to talk something. Yeah.
Yes, so participants can access their microphone.
Yeah. Go ahead.
Any questions is there?
Yeah. Yeah, Engineer Satyendra Prasad, you can go ahead. I think he want to speak something. Yeah, microphone is unmuted, no? Sahi?
Yes, sir. Yes, sir.
Yeah. Yeah, go ahead now. Yeah. Microphone is unmuted, no?
Yes, sir. It is.
Yeah, Engineer Satyendra Prasad, go ahead. Your microphone is unmuted. Yeah, you unmute and speak. Your voice is not clear.
Okay.
Otherwise, put it in the chat box also. Sir will try to inculcate in his talk. Yes, we are unable to hear you. Okay, meantime, sir, you go ahead. Meantime, so
Okay.
you go ahead as per your shot. Yeah.
IoT to tend to IIoT.
Yeah.
Yes. Once we are talking IoT, once we talk, it is a very generic. So once we are very specific about the technologies, it is the industrial terms we have to bring into the picture. Otherwise, meaning of the integrations is not at all. Once we talk about IoT, it is just the consumer IoT we talk, where you just communicate with any of a device, do some exchange of a data, that's it. But once you are utilizing it for any of a business intelligence, for any of a use cases, for autonomy, for the control of the any of a machines, for any of a specific industrial use cases, the IIoT will be discussed. I think, sir, previously slides were not changing. Am I right?
And now it's your slide is implementation. Industry 4.0 slide right now.
Yeah, this is.
Yeah,
right.
go ahead, sir. Yeah, go ahead.
Okay, so I will just quickly tell you about how it was the differences were there. So connectivity is there in the general industry process also. So here also we can have the integrations of the communications in the generic industry process. That's what the industry 3.0 we call. But in this, if you can see, only one side communication. There is a no two-way communications. There is a no top-down approach we have. It is the down-to-top approach. So like your HVAC PLC systems are working, and like if any of a order comes to you, for an example, so what will happen? The order will come to the top management level. He will feed it into the ERP. From the ERP, the MES system employees will prepare the number of products or anything that has to be made. He will feed into the SCADA systems, and from the SCADA system, the commands will be generated for the PLC devices through the interface, and the production will start. Now, what happens that if in a real time, the requirement of the product has changed, maybe some specification had changed, or maybe the quantities have changed, the person has to again come back to the channel from the ERP to MES to SCADA, and then the PLC system will make the effective control onto it. So in a real time, we will not be able to control the production processes if it is the 3.0 concept we are following. Secondly, in real time, the top level management will also not be able to gather that what is the production ratios, what is the effective production rate of his factory is there in a real time, because it is not a top-down approach we are having. It is not a direct communication the cloud level or a ERP level person is having on the PLCs. He has to go through the department by department. These all are the automated departments, but yes, department by department. But once we are implementing it into the means of the IoT and AI and everything, so it is a connectivity we are having together from the top level to the bottom. So on top, your business systems, operational systems, customer interactions, SCADA, everyone is there who are connected through the APIs and connectors to the low level things. And in between, these are the layers in between where the connectivity is direct between the business system to the things. The connector elements are your application programming interfaces. The gateways are there for the device communications. The automations we are getting through the means of the cloud connected interfaces. For communications, we are having the protocols like MQTT, REST, all these protocols, which is giving the real-time insight from the thing to the top level of the cloud. And also we are having the interface for the legacy items to connect. So if any older machines, old school is there, so that can also be connected with your system. So here in a real time, in this implementation, in a real time, the business system can get that what is the in and out throughput of the system is happening. The operational systems can know in a real time about the production volumes, the production ratios, the effectiveness of the productions. The customer interaction systems can tell in a real time about any of our faults, any of our issues, or anything that is related to any of our product. And using the SCADA, we can control directly on the connected HMIs, through the connected HMIs or the PLCs, so that we can get the real-time control of the systems. So the models will be implemented onto the top level, and the intelligence will be gathered through your devices, through the edge devices which will be there on the things. So things are your models. Things are your models, which is the software model of your hardware, which you are making through the means of sensors, through the means of the connections of the sensors and the firmware integrated with it, and then the control and communication that has been happening through the means of the cloud connected data. So there, this cyber physical system is actually the term that we use for these kind of ecosystem, where we are having the control, communication, and computation together. So your sensors are your nose. That is the IoT part of it. Those are taking care of the sensing of the data, gathering of the huge amount of data. The computation part is there, your intelligent machines, the intelligent edge devices, which might have the AI models also, the embedded AI models also. And then we have the communications. So for which we have the media, communication media, and the protocols integrated together, which is making the transformations and interactions and the controls of the physical world around us through the means of information. So any of a physical thing which you want to integrate into your system, first one, it has to be modeled in terms of a thing. That is, with the help of the sensors, you will model it. You will gather the data through the means of the sensors of those physical items, send it onto an edge device, make a computation, and then the communication will happen onto your cloud. And once all these data that you are gathering from at the cloud level from your devices will be processed, and the models will be utilized, maybe learnings could be provided, so that the next time, or maybe in a real time, whenever the control is going to happen of the system, it must be effective and accurate. So the precise productions or precise and effective uses of the utilizations of the machines. That's what we want by the integrations of the technologies. So this industry 4.0, that is all overall plethora of the industrial automation I'm talking about, which is the having industrial Internet of Things, the cyber physical systems. It will make a complete smart factory. The big data analytics is used over for the analysis of the real-time data which you are gathering. The preventive and the predictive maintenances are an integral part of it, which we are using or which we are taking the benefit of AI into this, and the sensors and the interoperability. So that is the sensors will be again your nose for the gathering of the data. And because all these systems has to be interoperable, has to take part from one to another. So that's where this terms are getting utilized. Some more things that we can get, like if we are not having these predictive maintenances, means based on AI, then the standard CDM techniques we are also using. So where we can keep monitoring the different of conditions of the particular of a machines, like vibrations, thereafter the shock parameters, the temperature, the current, everything from the machine, and based on what we can gather the any of a time that when the machine is going to be bad, and we can take the necessary parameters, we can take the necessary actions to keep it running. So IoT and AI together is this, where IoT is used for the sensing. It senses the data in a big data environment. It will store, it will save all the things. So it will keep the remembrance, it will keep it into the memory, which is used for the training of those AI models. And using these AI models, the decisions are made and the command is again being sent to the devices at the IoT layer to make the necessary changes. Like for an example, you are making, you are designing a device for controlling the infrastructure, or maybe some factory, or maybe some hotel automation system you are making. So maybe chillers are there. So a conference is there in a hotel, and the air conditioning systems are there using the means of the chillers. So we set it like that that meeting is going to end at maybe 9 p.m. in the evening. So there is 100% in the room. Now what will happen, that if we will shut off the air conditioning device at 9 p.m., what will happen? This room will still be chilled for next 1 or 2 hours. It will still remain cold for next 1 to 2 hours. So what is there? It is cold for next 1 to 2 hours, but the meeting has ended at 9 p.m. only. But till 11 p.m., the room is still in a cool state. So actually, we have overutilized the energy. We should have made it in such a way so that once the meeting is ended, within 15-20 minutes, the room should come in a normal temperature level. It should not remain cool for next 2 hours, because it is the wastage of energy we are doing. So what will happen? How we can do this? Just by means of the sensors, it is not possible. Because if we are just using a sensor, if we are doing, what will happen? We will be keep gathering the information of the number of people present in the room based on what the chillers we are controlling automatically, and it will keeping it cool and cool and cold. If the person if the persons will start leaving before 9 p.m., maybe at around 8:30 or maybe at 8 p.m. also maybe the persons have started leaving, what will happen? That it will sense the persons are lesser in the room. It will start heating, so which will be uncomfortable for the persons who are present till 9 p.m. So in both of the case, only by using the sensing, it is not a valid solution. Here, if we are having a model that during the meeting hours of evening, like the meetings which happen around 6 to 9 p.m. or maybe in the time period of a 6 to 10, or maybe the meetings of a particular company when happens during these hours, what is the average or what is the in and out ratio of the persons remain? If we have certain of a model, we can use this model, and based on this, if we start controlling the chiller, that might be a one effective solution for the keeping the environment controlled, for the comfortable for the persons, and also it will not be a wastage of the energy. So this is the one use case where we can integrate the technologies and make the effective use cases, and simultaneously can work towards the energy efficiencies. There might be hundreds of the models that you can develop based on the use cases and based on the requirements of your customer. So that is a one. Another is the connected vehicle I had talked about. So it is the together we are gathering the data through the means of the transportations, through the means of the sensors. We are gathering the data for the connected vehicles, which can tell not only the effective transportations of the vehicle, but also to the efficiency of the transportations. Because if we are having the data from the connected vehicle, so it will tell me all about the traffic status through which the vehicle is moving, and based on what we can plan that how many number of vehicles are moving on a particular stretch, what is the operational hours are there for the more number of vehicles, what are the operational hours for the lesser number of vehicles, how the driving pattern of the vehicles are there, and based on what can we plan some safety measures and everything. So we are getting the better insights with the help of these technologies. So there is a one a sensor, like we all are using some sorts of sensors for gathering the real-time data, maybe some presence of the persons, or detection of the objects, but integration of the AI with the sensing technologies, where we are having the 3D time of flight sensors. So here we can gather the without breaking the privacy of the person. So you can see here that the without breaking the privacy, like if I want to know that in an empty apartment, if the person is there, like the plan is there is a problem statement that in an apartment some elderly people are living. Now, without breaking their privacy, if I want to know that whether they are moving or not, whether they are moving okay or not in their apartment, or they are working fine or not. So one way is to put the cameras, but cameras will be breaking their privacies. So we can have here these model sensors, which can which can sense their movements, and based on what it can, using the models, it can tell me that whether they are moving properly or not, and accordingly the system, if any of emergency is there, so system can tell the effective measures to take care. So all these things are possible with the help of the edge computing. So on the edge nodes, the intelligent computing processors are there, which will be taking care of the gathering the data. And if the intelligent models you want to put, which we are doing nowadays with the help of the embedded AI principles on the edge device itself, so that the more and more data should not go to the cloud. It will not fill the cloud. It will not make the cloud costlier, and the processing time will not be higher. So on the edge level, we are doing all these things most of them, and the analytics level, we send the data to the cloud, so that whatever is necessary for making the models, that data will be traveling to the cloud level. The second of a thing that we use with the help of the AI is the predictive maintenances. So normally we have a preventive maintenance schedules where we are just waiting for the machine to break, or maybe we have a scheduled maintenance. So that is a historical thing. But now with the help of these sensors, we can have a continuous monitoring of the device, like any of a motor, or like here, any of a air conditioning system, for an example, if you have. So normally what it is, initially it is your warranty coverage is there. Then you have a time-based maintenance, like every 6 months you do maintenance. Then it comes after some years, it comes on a verge of a potential failure. And then the failure starts happening, like sometime the sensor will not work, sometime your compressor will not work, sometime your motor will not work. And based on that, condition-based maintenance you do. So first you do the CBM, condition-based monitoring, and then the condition-based maintenance that you do. And then at the end, it comes at a potential failure. Functionally, it becomes fail. But once we have the CBM implemented, then we can be gathering the real-time data from our devices with the help of the sensors. And then there are the intelligent algorithms will be there, which will detect in advance that the machine is going to fail. That might be a change into the temperature pattern of your motor, might be a change into the current consumption, might be a change into the vibration. And these things we can take into a model, and based on what we can flag in advance that the machine is going to fail. So these things, that's what will help us in advance with the for the effective maintenance and the effective utilizations of the systems. The AI with the advancements into the IoT, the billions of devices are going to be connected, and it is getting connected day by day into each of the domains, whether it is your personal, whether it is the consumer, whether it is the industrial, whether it is the global connectivity. Now, with such a huge connected devices onto the network, it becomes a very vulnerable for the security point. So any of a device can be compromised from any point, from anywhere, and your whole of a security is at a risk. So that's where also this AI models are used nowadays, where we can model the changes into the breach. So like if any of a, like you are having you are using a home automation system at your home, which is controlling the lights and fan parameters, gathering the data of your oxygen level within your room, gathering the temperature data, gathering the humidity data, all these things. Now, if someone has compromised and changed the settings of your temperature sensor parameters, and based on what, maybe your room has started heating, or maybe the AC is getting controlled remotely by changing just the temperature parameter. So just if these things are the possibility, then it is happening. So then what sort of measures we have to take care so that it should not, because for with each of the person, we should not be thinking that he will take care of each of the system which he has installed in his home. So there also these AI models are utilized, which can take charge of the changes, the sudden changes into the parameters of the data, and can filter out that the particular the sudden change into the data parameter has happened, and based on which the errors or the security measures that could be taken care. So these things are possible with the help of these integration of the technologies. Together. Then certain of the things I also want to. So here, like predictive maintenance, I was talking about. So there are the solutions are there. So I think screen is visible.
Yeah, it's visible, sir.
So like predictive maintenance things I was talking about. So you will have to first identify that what is the for which system you are going to design the predictive maintenance solutions, and mostly it would be related to the motor controls, the compressor controls, and everything, and then the connectivity which you are having. So this is under the AI and on microchip. Microchip is the largest semiconductor providing in this domain. So you can explore the solutions over here that is available with them. You can go like for BLDC motors or brushed motors, induction motors, which type of a motor that you are using. And in that, there are the particular of the solutions are available. You can go through their notes and can see that what they have implemented, block diagrams and everything that you can see, like compressors, like PMSM motors, they are there for the AC compressors or the drives. So there are the microcontrollers are there. And how do we take care of the developments? There are the libraries are available for that purposes, and you can utilize these resources together. Same is there for the embedded vision, like smart embedded vision if you want to do. So again, that is there.
Dr. Nitin want to say something? Dr. Nitin, sir?
Sure.
Go ahead, sir. Yes. Sahi?
Yes, sir.
Unmute to Dr. Nitin, sir.
Yes, sir. The microphone access has been given.
Dr. Nitin, sir, you can go ahead, sir, if you want to say something. I think
Okay. There is a one question: how to use the IIoT with AI?
Yeah.
So
go ahead, sir.
it is the actually I was talking that once it is the integration of your sensing through the means of the sensors, you are gathering the data. Just using those data, if you have to train, if you have to make effective use of the system, you will have to introduce the AI into this. So like for an example, it is the okay. So like you are gathering the data from the maybe some vehicle, that traffic data, like how the vehicle is the vehicle is moving. So the real-time traffic data that you are gathering, that is the means of the IoT only. Whatever the data that you are gathering, you are storing it into your server. That is just a means of an IoT. But once we model it, once we fetch those data, model it into using the languages like Python or other languages are there for the modeling purposes. You model it and then compare the real-time data which you are gathering now with the help of those models, and then generating the analytics of it, then generating the controls of it, like the vehicle has to go left, right, move, stop, or maybe it has to take a corrective actions. Then it is integrations. That's what we are doing. One more example, like maybe someone is in the construction industry. So there are the lots of construction materials are getting are coming to any of a construction site every day. Now, if I just want to identify the construction materials, or maybe just want to identify the quality of the construction materials, so what will happen? Using the means of the IoT and the cameras, we can gather the pictures of it. That is just a storage of the data that we are having. But if we have modeled a complete profile, if we have made a data set of the construction materials which we are using as a standard, and then comparing those data sets with the real-time data which is getting day by day from my construction site, getting the comparisons, and then generating the result outcome final for the quality of the construction material, or maybe the identification of the construction material, it will be a case of integration. So you will have to utilize the languages that is the embedded C level, C++ levels with the help of the sensors, and then send the data onto the cloud level either, or maybe you can store it at your edge level. And if it is a smaller data sets you are working with, and then the model you will have to make either at the edge level or at the cloud level, wherever is your use case, and then train your systems accordingly. Which courses should we take to have a career in IoT? Lots and lots of practice. There are the program. There are the lots of skilling programs are there. Like we also run. There are the industrial IoT programs are there. At SIRS College, we are having the Center of Excellence in Industrial IoT. So there are the lots of skilling programs you will find that is there, and that is apart from the normal your college curriculums or school curriculum, and you can take. So maybe you can go to our website also. There is the industrial IoT programs are there. There is a specialized programs, 6-month specialized programs are there, and that is having the certification from NOC and UK. After of this completion of this program, you can get the certification from NOC and UK, and there is a lots of placement opportunities are also there. So
yeah, participants, any other queries if you want to say? Durgesh is satisfied with your answer. Sir, you can give your website also if they want to.
Yeah, I'm just writing here.
So that they can get connect with you if they someone for some additional things they can connect.
This is a website.
I think a lot of activities are happening with you also, so you can try to highlight them so that few of them.
Yeah, so we are, as I told you in the beginning, that we are into design R&D with the lots of OEMs. We are providing the solutions for their problems related to the industrial IoT, the electric vehicle designs, thereafter the battery packs. Everywhere there is the IoT is there, everywhere the AI is there. So this is the courses as you were asking. So it is here, you can see the industrial IoT and IoT security program is there, 24 weeks program is there, specialized. So it is in a hybrid mode available. And here you can see we are covering all your things related to the Industry 4.0, microcontrollers, protocols, the cloud communications, the smart systems, the predictive, as I was talking about, all these things, integration of AI into this, integration of a security into the, and then the communication skills. So certification is from Drupal, NOC and UK, and that is, it is a one year of a support that you have after the completion of the program also. So you can go through our website and get the information. Which course is suitable for biomedical engineer based on IoT? See, the implementations for the different of the domains are separate. Like it is the medical IoT or biomedical, so there will be the more focus towards the low power designs will remain. So if it's a specialized course you are asking, so the base will remain the same. Like the course which I am telling you, we cover all these things over here. Once you are implementing the projects, there you will have to focus towards that which domain you are working. Because it is the same of a protocols, the same of a processor architectures, all these things will be utilized. Only the implementations are different. Maybe in medical cases, you will have to focus more towards the body protocols, the low power protocols, the low power implementations. Whereas once we are into the industrial designs, we will more focus towards the remote control of the devices. So as a course, it is the same of a things, but yes, implementations wise, you should more focus towards your biomedical engineering or maybe medical engineering. But still, if you find any, I'm not remembering anyone, but still, if you find any medical IoT related program, MIoT, that would be a beneficial for the biomedical engineers.
So Pragyanika, the specialized in especially IIoT, industrial IoT. So I think you have participants, they have a knowledge of AI, ML and IoT, how they can proceed further level. If you have still queries, you can, sir has given already website, but still if as sir is busy, but with our request, sir has found time. So if you have some queries, you put it. So
Here
that's
is my email ID is also I'm writing. So if anyone wants
yeah.
to connect afterwards, you can note it down. It is amit@pragyatmika.co.in. So you can drop me a message. We will connect you with this. So we are having trainings, development consultancy, everything.
Yeah.
Yes, sir. So, thank you so much, sir, for sharing your insights with us today. I think it has given us a new industry perspective as well to what we have been learning since 1 month. So, sir, once again, I would like to extend a formal thank you on behalf of IT Pune chapter and Buds Engineering Academy since you have joined us with a very short notice. So, thank you so much,
Thank
sir.
you. Thank you.
Yes, sir.
Thank you so much, sir. Amit sir, finding
Okay, sir. Good
with
night.
short
Good.
notice. Thank you so
Thanks
much.
everyone for the patient listening. It was just old.
Amit sir, for jobs, something is saying Pratik.
Okay. Okay. Okay.
But CV, okay, for job CV. Okay, okay. Okay, 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 okay. Yeah, yeah,
Should I continue, sir?
yeah. Go ahead. Go ahead. Yeah, go ahead.
So yes, thank you so much, sir. After this, let's dive deep into the webinar once again. Just give me a second. I will share my screen.
So you are busy, Amit sir, but you find time for us. Thank you again.
Yeah, I was traveling, sir. So just you said whatever the thing was there. Hope I have not bored any participant.
Yes, so I guess my screen is visible, and so should
Yeah,
be.
yeah. Go ahead. It's visible. Yeah, go ahead. Yeah, go ahead.
So, yeah. So it's been almost 1 month, and last week we also had an opportunity to learn about deep learning, wherein we have understood the basic concepts of deep learning, right? So before I dive into the session, I would like to ask all the participants a very simple question. What do you mean by algorithms? You can put it in the chat box. A simple question. What do you mean by algorithms? 10 seconds of time. I suppose I see answers in the chat box. Yes, algorithms are stepwise instructions. Very correct. Now, the second question. I will give you 10 more seconds. I want you all to name some deep learning based applications in the chat box. The second question, name some deep learning based applications, real world applications in the chat box. Okay, I could give you all a image based hint. You can see different images over here, and this is a hint for the answer. Yes, very correct. Chat GPT. Yes. Then we have Alexa, that is a voice based virtual assistant. Then object detection and image detection. Right? These are also few applications. Right, very well. So basically, what we're going to do right now is I'm going to be giving you a brief overview of the deep learning basics that we have already covered, and after within 5 minutes we will revise that, and then I have an activity for all of you where we are going to develop a model, a deep learning based model, right? So basically, to understand deep learning, we can compare it. We can think of a neural network as a computer system which can be inspired by how our brains work, right? Just like our brains has been interconnected through neurons, they process information. In a very similar manner, they are interconnected by nodes that process data, right? So this is a very simple image that can compare the human brain to a neural network, right? So this is the basic definition. Moving on, you have three terms over here: nodes, weights, and layers. Uh, Make sure you understand these terms because in forward we are going to use these terms. So neuron is basically the smallest unit, right? So in a neural network, each of this each of this neuron is also called as nodes, right? And these nodes are connected with some connection, and between these nodes they have some weight which determines the strength of this connection, right? So these weights are then adjusted as the network learns, and then these neurons are organized into different layers: the input layer that receives data, the output layer that is going to give us the final result, and in between there are one or more hidden layers that process the data, right? So these are the three words: nodes, weights, and layers. You might be already familiar. We are just giving it a brush up. Now, next is patterns and learnings. So we all know that neural networks learn by recognizing the patterns from the input data, right? So just like we learn how to recognize our friend's face, neural networks learn to recognize patterns in things like image, text, or sounds, right? So this is basic flow diagram that is just giving us a brief overview of how patterns and learnings work. Now, next is the feed forward process, right? So, imagine you're teaching a neural network how to recognize flowers and trees in pictures, right? So, you show them a lot of pictures, and in a process called feed forward, what happens is the input data, say for example, it's an image. Then pixels of this image goes through the network layers, and each neuron will calculate a weight of its input. Weights are nothing but the interconnections that we just saw in the previous slide, right? It is then applied to some kind of a function, say for example, some activation function, just like our brain deciding different things, right? Then after this, it would decide if it should send the signal to the next layer or not. So it is a feed forward process, right? Then next is our back propagation. Now the term says back propagation, right? So say for example, let's continue our example of trees and flowers. So after we make a guess whether a picture is a tree or a flower, then the network will compare its guess with the actual answer, right? So if it goes wrong, then it will adjust the weights. Weights, you all know what it is, interconnection between the nodes. It would adjust the weight to make the bit and make a better guess next time. So this process of looking back, right? So this process of looking back and improving the mistakes and then correcting them is called as back propagation, right? And so this is what deep learning is summarized. When a neural network has multiple hidden layers, say just one or more than one, then we call it deep neural network, right? So deep learning involves training these networks to automatically learn more complex patterns, say in data, or for different tasks like image recognition, language translation, or even playing games, right? So it is basic. Deep learning is having endless possibilities, okay? And we can find insights also that might be difficult for humans to discover, right? Like driving self-driving cars that we have already seen, generate human like text like chat gpt, and many much more, right? So now I have an activity over here for you. So basically, you can just take a piece of paper and pen, or you can just directly type it. What I want you all to do is, we have to create a flow chart to teach a computer whether a picture is of a cat or a dog, right? So I will put a timer of say around 4 minutes. I guess the timer is also visible. You can take a piece of paper, write it down, and send it on the WhatsApp group or directly type it in the chat box. So basically, you have to create a flow chart or a stepwise, diagram kind of thing, which would help us design a model that would teach a computer or any kind of device to determine if a picture is of a cat or a dog, right? So here you go. You have 4 minutes of time. You can just confirm in the chat box so that I know if you're doing the activity or not.
Participants can respond in the chat box, or you can use a WhatsApp will enable there. Create a flowchart to teach a computer to tell if a picture has a cat or dog. So flowchart you have to create it.
Yes, you all are very familiar about how flowcharts work, and you are also familiar about deep learning. And I've just given you a quick overview of how deep learning would work. Okay, we have a response in data set. Any more responses? Or you could just type it step 1, step 2, step 3, and so on. What should be the first step, the second, and so on, so forth. Yes, you have almost 2 minutes 30 seconds left. Okay. Just make a very basic stepwise, diagram or something. Yes, Durgesh, Gitika, Mamta, Sai, Swati. Okay. A simple flow chart or an algorithm. Yes. Step 1 is to import data of images. What would be the step 2? Guys, you need to think because we've been doing this since like 1 month. Okay, so last 40 seconds. Okay.
Okay. Yes, there is some.
Okay, so I guess I will just reveal it. Okay. So, very first thing, I've already got an answer. The first step is data collection, right? So, first step is to getting ready. I've put two terms over here. One is a technical term, and I've also explained it in a very layman words, right? So first step is data collection, wherein you have to get and collect a lot of pictures of whatever is desired. In our case, it's cats and dogs. Then the second step is pre-processing. That is nothing but the learning steps. That means in here we can say that each node or each neuron is just like a detective, right? So if a lot of detectives work together and they make tiny decisions, and then they can deliver the output very well, right? So this is pre-processing. The next one is guess and compare, which we can also say in technical terms is the training process and the forward pass. We have seen already what the forward pass is in the previous slide. Then is fixing the mistakes. So once they have detected or they have at least made a guess of what the picture is, we have to tell them what the mistake is, right? So that is loss calculation and back propagation. That means whatever the response has been given, you have to compare it to the exact answer or the real answer, and then that would help the neural network make a exact response the next time. So this is back propagation and loss calculation. Back propagation is also learning from your previous mistakes, right? Then the next step is teamwork improvement, and the practice makes perfect. So basically it's nothing but validation, right? So validation is a separate set of data which is used to check how well the model is doing during the training, right? So in layman words we can say it's teamwork and improvement, and making this process repeat many more times so that it becomes and gives us a perfect answer every time, right? Then the last two steps is testing. You give them more and more new pictures to make accurate decisions, and then the last one that it is ready for deployment, right? So it's a very simple deep learning model that we have created right now to determine if a picture given is of a cat or a dog, right? Now let's move on. Here we have four algorithms that we are going to study. The first one is a convolutional neural network, right? So basically, okay, yes, I will show you an image, right? So you can see this image wherein it's a representation of how the convolutional neural network works. It has different layers and it has different steps. The very first one is convolutional layer. So basically, imagine you have a magnifying glass in your hand, right? And you move the magnifying glass over this picture and look at it at small parts, right? For example, here there's a picture of a zebra. So say using the magnifying glass, I'm looking at the leg of the zebra. So what would happen? I am able to see a zoomed version of the specific part, right? So similarly, what the convolution first step is, it basically looks at small sections of the images like tiny squares. These tiny squares are called as kernels, right? And after looking at these tiny squares or kernels, what would happen is it would try to find patterns like edges, corners, textures, colors, and these patterns are called as features that help the network understand the image better, right? So this process is called as the first step of feature extraction. That means it is understanding the different patterns of the given image, right? Now the second layer or the second steps is nothing but pooling layer, right? So we all know what sampling is. What is sampling? Small parts or small bits, right? Now what pooling is down sampling. As in, imagine the same magnifying glass thing. Using the magnifying glass, we have already seen the zoomed version. Now you're zooming out a bit after examining the picture from a very closer view. Right now, what would happen is the pooling layer is doing something similar. It would take a bunch of the neighboring pixels and then it will keep the most important information. So this helps it reduce the data size and makes the network focus only on the essential features, right? So this is called as pooling. Now pooling is done in different layers or multiple layers, right? Now next thing is fattening. So once after pooling, we have the specific pixels only, which has essential features. Now this is a 2D grid. Now we have to make it into a data sequence of one dimension, right? So what this layer would do is, this is like taking all the highlighted parts of the images and putting it in a line so that the network can understand them better, right? So first step we have zoomed, second step we have just seen the essential features, and third step we are making a sequence, or we are putting them in a single line so that we understand, so that the network understands it better, right? Now after the flattening layer is the fully connected layer that you can see at the right hand side. So now let's say the network has learned the features of the image, right? Now it is the time of the network to take decisions or to make decisions, right? So the fully connected layer is like your brain's final decision making stage, right? It takes like all the patterns and all the information that it has observed from the previous layers, and it figures out the image that mostly, or closely represents what it wants. Like say for in our case, if it wants a cat or a dog or something else, right? So this is called as the operation of the fully connected layer, and it is also called as the classifier, right? Now the last step is called as the output layer. Finally the output layer is going to give us the result. So it gives you like a prediction about what the network thinks of the given image, right? So for example, if the network is trained to recognize animals, in our case it's a zebra, so it can be like 20% horse, 70% zebra, and 10% dog, right? So it is giving us some output in such a kind, right? So this is nothing but convolutional neural network, right? Now, okay, yes. Moving on next. Okay, I've not added a Python code of the same network. In here, I have just added a basic algorithm of how it would work if we have run the code. So the very first one is getting ready. You need to collect images and each picture to the specific group that we want. Say animals or food or trees, plants, etc. So the first step is nothing but labeled image data set. We need to create a data set. Now the second one is load a pre-trained model. So it is like using a smart system or a smart tool, like a pre-trained model. Like if I give an example, it's like borrowing your friend's homework, but in a good way, right? This is nothing but loading a pre-trained model, right? Now next thing is making adjustment. Continuing with the same example, say you have borrowed your friend's homework. Now you have to customize the borrowed stuff in your own model so that it recognizes that it's your work. So it's the same thing. The third step is nothing but model adjustment, right, to the specific application that we want. Say if we want to determine a group of animals, right? Now next thing is adding new layer. So it's like adding a special knowledge to the borrowed homework, right? Then you have prepared your pictures. So you just try to give it a makeover by making the same size or adjusting the colors or something like that. So this is nothing but data pre-processing, right? Now after pre-processing is the training time, where you teach the model. So you show it a lots of pictures from each group, and then you tell it which group it belongs to, right? Then is the evaluation part. So what would the evaluation part do? Is like checking your results. You give it some pictures before it has never seen it before, so that it can at least guess which group it belongs to, right? Then next is making predictions. That is the prediction step. So you give the model a new picture, a total new picture, and you tell the model which group it belongs to, right? Then is the fine tuning. So fine tuning is like improving. So if the model doesn't do the perfect job, you can fine tune it a bit. That means it's like practicing something until and unless you get it right, right? Then is the last step, that is the outcome or the output. That is where you have got like you have created a smart tool that can guess any picture you have given, right? So this was convolutional neural network. Now moving on to the recurrent neural network. So can anyone give me the meaning of recurrent in the chat box? Okay, no problem. Okay. So basically, let's first understand what sequential data is. So if I give an example, imagine you're telling a story to someone, and then each sentence will follow the story. So the order does not match, right? It's like a chain of events you're explaining, and what happens next depends on what happens before. So it's a sequential data, or we can say it's a series of data in certain order, right? So what are RNNs, or recurrent neural networks? So it's like a special type of computer that is really good at understanding these stories where one thing leads to another, right? As in, they work recurrent or a sequential manner, right? So they are, they can learn from the earlier story or the earlier data and make a sense in what the future is going to happen. So basically, RNNs are like a special kind of neural networks that are good at handling sequences, right? Now, next thing is memories in RNN. Obviously, it's going to determine or understand the past data and then tell us what's going to be the next sequence. So obviously, it's going to have a good memory, right? Now, the next thing is applications of RNN. So first things first, language modeling. It can be used as a language modeling, which helps computers, or it would help people how to talk and turn their speech into written words. That is Google Assistant or something like that. The next is music creation. It can create tones and remember the notes that they have not heard before. And then it's like a time travel also. It's a time series prediction. That's one of the applications where if you want to guess what's going to happen next, RNNs can help you there, right? Okay, so this is a basic algorithm again of our second type of neural network, that is recurrent neural network. Same thing, but there is some difference in here. First thing is getting ready. That means you collect text. Okay, this algorithm is basically going to help us text generation using RNN, right? So first things first. First thing, collection of text, sentences, stories, articles, etc. Then second thing is pre-processing. It's like cleaning or splitting it into smaller parts. That is called as tokenization. And then after that, the third one is building the RNN model. So RNN model is like making the brain. So if you think of a building robot that learns how to write, then this robot's brain will be an RNN model, right? Then next one is the learning process. That is time to train the model, where pre-training the data, you pre-train the data. And then the next step is text generation, right? So it's like you are asking a robot to start a new sentence where you have given the first few words of the story, right? And then it takes these words and tries to guess what the next words should be. A simple example to the algorithm. Then if say for example the robot wants to add a special adjustment, say called as temperature, right? So a higher temperature makes the robot, say for example, more informative, while the less temperature would make the robot, stick closely to what it has already learned, right? So you can add a parameter which would control the randomness, right? And then the last step, where you get a generated text, right? Okay, so moving on, now we have studied two models. One is the concurrent one and one is RNN. Now there is a vanishing gradient problem that happens in RNN. So let's continue with the robot example. So if you think of a teaching robot that would predict the weather using the past data or the historical data, then the robot learns by looking at the past dates, right? Because that is what it is meant to do. But when it tries to learn from the data that is very far back, okay, like it's like trying to remember from a very past memory, or what can I say, a distant memory, the robot can't learn well from those days, right, which is very past. This problem happens in some types of computer learning, like when dealing with sequences. So in here, this is called as the vanishing gradient problem in RNNs, right? So that is what, why we move on to LSTM, that is nothing but long short term memory networks, right? Yes. So LSTM networks are like the smarter versions of RNN, and they are designed to remember important information from long time without fading away. Right. So basically, LSTMs are like they have doors in their brains that can open or close. When new information comes in, they would decide whether to keep it or forget it, right? So it's like when you are packing for a trip, you keep the important stuff and leave the less important stuff behind, right? So this is nothing but like the memory doors. So in technical terms, it's called as memory gates, right? So it would remember the relevant information and it would forget the unimportant information, right? So there are these three different types of doors. First one is the forget gate, the input gate, and the output gate, right? You can understand it from the name only. The forget gate decides what to throw away. The input gate decides what new information to add to its memory, and the output gate would decide what to use from the memory to make a prediction, right? So this is nothing but long-term and short-term memory. Now, yes, let's move on to the next one. Okay, yes, yeah. Now we have not seen, we saw the vanishing gradient problem, and we have also seen how it vanishes or how it is solved in the LSTMs, right? So this is what it says. Yes. Now the next one is exploring gated recurrent units. Now this is like the next version of LSTMs, right? So it's like imagine if you're trying to remember important things like a step, something that is stepwise, right? So GRUs is going to help us to remember some kind of task or understand how to work with it when there is some kind of stepwise thing happening. Like for example, if you want to remember some kind of recipe, right? So it would help us use a simple recipe instead of complex one, where the number of steps in the recipe are less. Yes. Okay. Yeah. So one second. Yeah. So the first thing is update gates in GRUs. So say picture is like a gate which helps us decide if the new information is worth remembering or not. Right? It's like when you have to decide a new piece of information is important enough to keep it in your memory or not. Right? The next thing is update gate. It is going to help us add new information. You can read it since I think it's already 7:59. Okay. So the next one is the reset gate operation. It's like the name says it all. It's like clearing the mind. And then the hidden state. So hidden state, it's like combining the old one and the new one, right? Okay. So I don't think so. It's already time. So we have one more algorithm left, transforming with transformer architecture, but we would continue it in the next lecture or so.
Okay.
Okay. So I would just end the session, but before I end the session, I would like to ask all the participants one question in the chat box. What is the full form of Chat GPT?
Yes,
What is
Chat
the full
GPT.
form of Chat GPT?
Yes, anyone?
Okay, no problem. You can Google it later on. Yes, sir. So, should we end the session now?
So I think we are at the closing, and I think feedback links are already shared, no?
Yes, sir.
Yeah, feedback links are already shared. The feedbacks is compulsory. Feedback is for the certification. We are at the end of the session, And tomorrow is our last session. That is a closing session tomorrow. So we tried to, yeah, Chat GPT Pratik has given something. So participants are requested to fill the that feedback forms, whether to get the certification from IETE, New Delhi approval, your record of feedbacks and attendance is to be submitted. Then only you'll get the certification from that. So please submit the feedbacks. With this, we'll end today's session. Yeah,
Yes,
go
sir.
ahead.
I will end today's
Yeah,
session.
yeah.
Thank you, participants.
Tomorrow will be the last session. 31st August. Tomorrow will be the closing last session. Yeah.
Yes.
Okay. Okay.